Welcome everyone to the second day of 2012 CAFIT. For those who still wonder, CAFIT means California Friends Forum on Energy Efficiency Technologies. The theme of this year, Smart City, what's the added value? Welcome, we had a full day yesterday and we have a full interesting morning until 12:30 today. I'd like to introduce our first keynote speaker. We had a last-minute change in the agenda. Mark McGranagan was not able to come. But we have the pleasure of having Don Von Dollen as a keynote speaker this morning. Don Von Dollen is a program manager at the Electric Power Research Institute. He's responsible for the IntelliGrid program, which is focused on conducting R&D on communications and data integration for transmission, distribution, and consumer applications. Don Von Dollen has been chairman of the IEEE PS Intelligent Grid Coordinating Committee, and he has many other important roles in many organizations with acronyms I don't always know, such as DOE, EEI, NIST, NEMA, NARUC, and CSR. Don Von Dollen led a team of industry experts to develop a roadmap for the development and harmonization of smart grid interoperability standards under contract to the NIST, National Institute of Standards and Technology. Don has worked with several utilities on their company-specific smart grid roadmaps. And before joining EPRI, Don was a research engineer with PG&E. Please help me welcome Don.
Thank you. Can you hear me all right? Well, thank you. Mark McGranagan was the scheduled speaker for today, and Mark has a family emergency that kept him back in Knoxville. It's an honor, it's a pleasure to speak with you today. Okay. Thank you for your patience. So I manage our IntelliGrid program at EPRI. IntelliGrid really focuses on information communications technologies that really enable smart grid applications. What I want to talk about today is some of the work that we've been doing recently. I've been doing work on smart grids now for 11 years at EPRI. It goes by fast. For the past few years, we've been developing a number of smart grid roadmaps. And that's one of the things I'd like to talk with you today about, is just some of the findings from our roadmaps. We've worked directly with electric utilities, 10 electric utilities, to develop company-specific smart grid implementation roadmaps. And on these roadmaps, what we do is we work with the utility to establish a vision. So what is a smart grid for that company? And I have to tell you, so far there's been no two utilities that have exactly the same vision for what a smart grid is for them. And then what we start to do is identify what are the actions, the steps that are needed for that company to actually build out and realize that smart grid vision. That's an implementation roadmap. Another type of roadmap that we've developed is a technology roadmap. And we had a contract from the California Energy Commission, and we worked in partnership with the 3 California investor-owned utilities to develop a report on the smart grid vision for the state of California in the year 2020, and then identify a technology roadmap. What are the technologies that are critical to achieving that vision for California? And then trying to understand what the maturity of each of those technologies is. So that's a technology roadmap that we've developed. And then what we did was we used that technology roadmap as our starting point when we started to develop the research and development roadmaps within EPRI. Right? This is starting to look at how do you start to close those gaps on those key technologies that are going to enable this smart grid. So what I want to talk to you a little bit about today is some of the results, some of the findings from our smart grid road mapping work. Then I want to start to draw comparisons between smart grids and smart cities. How do we start expanding smart grids? How do smart grids start to relate to smart cities? And then talk about some demonstration projects that we're working on that start to demonstration projects for smart grids, but also that start to touch on the concept of smart cities. So starting for drivers for change, right? The electric utilities have been in operation for 100+ years. They have, for the most part, very mature processes on how they do things. And these processes have really been refined and honed after years and years of operation. So to get utilities to actually change those processes requires drivers. So these are some of the drivers that are forcing changes within the utilities. One of the biggest drivers is reduction of greenhouse gas emissions. That's one of the largest drivers within the industry, and I think that's common within the US as well as in Europe. That leads to us to starting to integrate more and more renewable resources into the grid. So bulk renewables into the transmission grid and distributed renewables into the distribution grid. Using electricity more efficiently. This is both on the grid side, so looking at ways that we can start to reduce the losses on the grid, look at conservation voltage reduction options, working with consumers to promote efficient behaviors for consumers. Effectively managing aging infrastructure, another commonality between the European grid and the US grid. We have very mature is a nice way of saying old. We have very old grids with some very old assets. And so a key challenge for us is being able to manage those older assets. Interesting one, meeting increasing consumer expectations of service. And in an age where we have almost instant information at our fingertips, trying to explain to consumers that the only way that a utility knows if power is flowing to your house is if you call them and tell them that the power is out. So the typical interaction between utilities and consumers has always been two things. It's either the monthly bill or it's when the power goes out. Those are typically the two times that you start to interact with a utility. And so in customer expectations, customers expect more. Customers expect more information. Customers expect better tools on how to manage their bills, their energy usage. They want information on what type of a carbon footprint are they leaving behind. So meeting these new expectations starts to become key. One of the things that helps us is leveraging the advances in communications and information technology, tremendous advances that we can start to take advantage of. But one of the things to really keep in mind is addressing all of these drivers in a cost-effective way. We need to, the goal is we have to keep electricity rates low. So starting to create what the vision is of a smart grid, we start to kind of put this picture together. So one of the things that we start to look at is a tremendous amount of sensors being put on the grid, sensors like a smart meter that really reports back the customer consumption behavior, looking at asset health monitoring sensors, looking at sensors like phasor measurement units, which are highly precise measurements of voltage and current and phase on the transmission system. So starting to collect a tremendous amount of data. And then having the analytics that are going to start to convert that data into actionable information. So really being able to process all of that data that's being generated. Communications networks, from home area networks, field area communications networks, wide area communications networks, moving that information from where it's created to where it needs to be, where the action needs to be taken. Integration of electric vehicles into the grid. On the distribution system, moving from a traditional distribution system that moves power in one direction, from the generator to the point of consumption, and making the distribution system more bidirectional as we get more and more generation put out on that distribution system. That changes a lot of conventional design philosophies around the distribution system. And providing customers with more information. So more information, more choices, more options. So the vision starts to, at a very high level, is very common as far as what a smart grid is. When we start to look at specific states, countries, utilities, companies, that vision starts to differ because different utilities, different states, different countries have different priorities. So the overall vision is different, but the order in which they're going to do things is going to be different based on those individual drivers. So legislative policy, regulatory policy, those have strong influences on what the overall vision is going to look like. R&D roadmaps. I should point out this roadmap is developed by the European Union. It's their strategic research agenda. This was an update to the roadmap that was developed in 2007. Came out in April of this year. I mentioned earlier, EPRI's done a series of R&D roadmaps. These are great tools for collaboration. One of the things is that there's no organization that has all of the funding, all of the resources needed to do all of the research and development that's needed for a smart grid. There's just a tremendous amount of work that's needed out there. So the drive to collaborate is critical. We have to be working together. We have to be leveraging each other's work. The roadmaps are a great tool for doing that type of coordination and that type of leveraging because it starts to say, okay, this is what we think is needed based on our perspectives, and you can start to compare with others. And then you can start to identify, okay, well, you're going to do work in this area, we'll do work in this area. One of the things I want to share, this is a list of lessons learned from the company, the utility-specific implementation roadmaps that we've developed. And I'm not going to go through all 11 of these items. I want to just focus on a couple of the items. So I mentioned we've worked with 10 different utilities developing company-specific smart grid roadmaps. Item 3, a successful roadmap must take a holistic approach. That sounds simple. It's not necessarily simple. Utilities tend to be very siloed. And there's very strong reasons on why they've been siloed. But they're very siloed into their particular domains. When you start thinking about implementing a smart grid, it means that you really have to break down those silos because the information communications technology infrastructure that's going to be deployed to support smart grid applications can support multiple applications in different domains. So same infrastructure could support distribution planning. It could support transmission operations. It could support information going to the customer. So breaking down these barriers and starting to think broadly, how does an infrastructure support multiple applications in a number of different fields? The other one I wanted to point out is number 4. Successful roadmap puts the customer at the center. And it starts to really focus on what are the needs of the customer. And so when we start thinking about that, as we started working with companies on their roadmaps, it was very easy to start thinking outside of just the utility box and starting to think in a broader term. So things like smart cities, thinking about how a smart grid can turn into a larger concept of a smarter city. So leveraging infrastructure to support even more applications, gas applications, water applications, telecommunications applications. Looking at vulnerabilities and risks, but looking at them holistically, and common cause failures. How does a vulnerability in one infrastructure overlap and impact another infrastructure? Electric transportation, energy integration, things like combined heat and power, and more providing consumers with tools that really fit into their daily lifestyles, really become tools that they use in other parts of their lives. They can also be used to support, again, electricity, water, gas, those critical infrastructures. So what I'd like to do is just share with you some of the demonstration projects that EPRI's involved in, demonstration projects that we're not necessarily involved in that are going on in other parts of the world. 4 years ago, we started an initiative called the Smart Grid Demonstration Initiative. This was to work, and right now we have 25 utilities that are participating in that. A number of those companies are doing demonstration projects, demonstrations of a smart grid. So large-scale demonstrations of these projects. We have a number of projects in the United States. We also have projects in Europe and in Australia. So this really is a global activity. One of the projects I want to share with you is with Kansas City Power and Light. And what they are doing is they're taking an underserved area within urban Kansas City that really needs to be revitalized. And they're applying a lot of the smart grid concepts to this particular area to see if they can rejuvenate this overall area. So things like integrating solar, biofuels, incorporating demand response, putting storage in on the generation side. Within homes, they're going to be putting in home area networks. They've installed 14,000 smart meters, looking at ways of in-home displays, digital thermostats, trying out different rate structures, time of use rate structures, and other types of dynamic rate structures, really in an experiment to see how do customers respond, what's the response that they get back from customers. Also incorporating larger buildings, so and tying into the building energy management systems, putting rooftop solar on these systems, demand response for commercial as well. And very important, starting to tie all of this into a tool that can go back to grid operations. And to do it not in a one-off way, but to try and make use as much as possible of the standards that exist in the industry to make this reproducible, and not just within Kansas City and Power and Light, but in other places as well. Another project I think a lot of people in this room are familiar with is the Premio project at EDF. This is a really exciting project. Similar in a way to the Kansas City Power and Light, they're tying in 8 different types of distributed energy resources, but again, tying it into the operations of the utility. And so this was actually this is in operation. It's been in operation since 2011, the first phase of the project. And so a lot of good results are coming out of this. One of them is the visualization tools for the operators. How do they know what resources are available to them at any given time? Another demonstration project is the city of Malmö in Sweden. This is really looking at 8 different high-rise apartment or townhouse complexes and starting to tie in looking at distributed generation, demand response, looking at providing consumers tools through home area networks, smart meters, feedback display devices, looking at different types of rate structures, and also looking at the mobility aspects. What are the types of apps that people can put on their smartphones and their tablets? One of the largest demonstration sites is in on Jeju Island on South Korea. It's an island at the very southern tip of Korea. And this is a public-private partnership. This is the vendors, technology suppliers, and the Korean government really teaming up to start to put into operation a number of Korean-developed technologies to support the smart grid. Things like energy storage and integration of solar photovoltaic systems, offshore wind power, smart meters, in-home displays. But this is really meant to be a Korean technology showcase. So a lot of Korean companies trying out their technologies and the Korean government giving them a place to try out their technologies to really understand performance, interaction between technologies, and then also the business processes that are going to be needed to actually support these types of smart grids. Japan also has a very similar effort going on on the western edge of Japan is a demonstration site very similar to Jeju Island. So I was talking about our research and development roadmaps. Just to talk about some of the key challenges that we've been identifying. Standards and interoperability. This is a big effort, a big challenge within the industry to really create the standards that enable us to start to get some level of interoperability between components and systems that make up the smart grid. Communications technologies, security and privacy is critical. Being able to integrate renewable resources and storage. One of the ones that we identified as being a major gap, and a number of people are working on this right now, is this idea of data management, analysis, and visualization. Right? How do you take the tremendous amounts of data that are coming out of the smart grid, apply the analytics, develop the analytics that allow you to start to convert that into actionable information, and then developing visualization approaches. How do you show an operator, or how do you show a planner or a maintenance engineer what is the information that's coming from the data? So to this end, one of the new initiatives that we're just in the process of launching right now is called the Distribution Modernization Demonstration. And we're looking at one aspect. So we're really looking at kind of modern distribution systems. And one of the things that we identified is the distribution system with smart meters being deployed, with increasing amounts of distributed generation being deployed, and monitoring systems going on the distribution system. That's really rich in new data that's coming in. So we're launching an initiative, a demonstration initiative, very similar to our smart grid demonstration initiative, working with a number of different utilities to first identify applications, where are the priority applications, working with universities and the research community, looking at effective methods for processing big data. And then we have a number of utilities that are ready to do implementations and demonstrations of new concepts. So it's an exciting time and an exciting project for us. One of the things that makes this particularly interesting is that demonstration aspect and the commitment from utilities that say, if we see an attractive application and an attractive technology, we can start to blend it together and demonstrate it. And then one last comment on collaboration. I mentioned interoperability is really one of the key barriers, and it's one of the key opportunities that we have within the industry for creating smart grids. And this was actually identified in legislation back in 2007. And NIST, the National Institute of Standards and Technologies, was given the responsibility of developing a smart grid interoperability framework. And to help them in that process, they created this public-private partnership, this organization called the Smart Grid Interoperability Panel, that really is meant to be a group that assists NIST in achieving that interoperability framework and creating that. So this is a wonderful collaboration. It's not just a US effort, it really is a multinational effort to really identify the areas of interoperability that need to be addressed, identify the standards that already exist, and help promote the use of those standards, and really looking for gaps in the standards landscape that need to be filled. So with that, let me conclude my presentation. And Gabrielle, if there's time for questions, I'd be glad to answer. Yes.
Thank you. It was very, very interesting. Of course, the smart grid has a cost. And do you think that there are enough cost-benefit analyses of the smart grid to be sure that we need it and we have to implement it?
It's one of the really strong needs, I think, that we have in the industry right now. It actually became one of my hobbies, was starting to collect cost-benefit analysis for either smart grid applications or smart metering. And they're a lot of fun to read. The problem is there's not a lot of data on the realized value that have come from the smart meters that have already been deployed. And that's one of the things the industry is really crying out for, is that they really want a documentation of the value that utilities have received from their smart meter deployments. And we're starting to see some of the utilities that were early adopters that are making efforts on tech transfer. In particular, I just saw a presentation from Encore Electric on the values that they're receiving from their smart meters. But this is one of the work, in fact, that EPRI is going to be doing next year, is starting to compile a lot of the realized values from AMI systems, because we really do need to understand that. When you go back to what some of the original business cases, cost-benefit analysis, were done before deployments, and now you look at them and reflect on them after they've been deployed, a lot of those benefits have never been realized. Having said that, there's a lot of benefits that were never anticipated that they're actually receiving. So we really need to have that type of information.
Righty, I'm next. Don, Ingrid Brown from the Electric Power Research Institute. Don, my question had to do when you listed the top 10 challenges. Did you list them in order of the most challenging to least challenging, or how were they arranged?
No, there's no particular order to those. Okay. Those were just the list that we had developed. So there's no particular significance to the order of that. Just to kind of tee up a later presentation, if I were to say one of the biggest challenges is security and privacy, if anything, that would probably be at the top of the list.
Maria Martin with Iberdrola from Spain. I would like to ask you about the international participation with the group, with the interoperability panel. If there is a huge international participation in it.
I wouldn't say it's a huge international participation. There's a number of agreements that have been signed with different countries. So Japan, Korea, the European Union have all signed memos of understanding with the Smart Grid Interoperability Panel. And there's some excellent collaboration that's going on right now in the architecture area, where a group of the architects from the European Union and the architecture committee within the SGIP are collaborating on the architecture of the smart grid right now. So some really good collaboration that's going on between the U.S. and Europe right now. Yes.
Hi, Don. Paul Bertrand for Smart Future. I was part of the Premio program in France, and we observed that it was really very important to put the customer in the center, and you pointed out this very important point. And at the end of the day, what happened in France with this Premio program is that the business model with the end user is still not clear. Due to the fact that the cost of the electricity is quite low in some parts of France and in Europe, and also in parts of the US, there is no really impact on the revenues of what smart automation, home automation, smart grid system in homes could really driven the fact that the people may accept to have systems with 5 or 6 or 7 years of return in investment. And I would be happy if you know a way to achieve this, because I think this is kind of a chicken and egg problem. We have to solve this before there is an acceptance by the end user. And all the program should seek to have solve this problem of the smart grid that works on the grid but doesn't work on the homes. And this might be a different target from the two programs.
That's the putting the customer at the center is just so critical to all of these. And we've seen issues, we've seen them in the United States, we've seen them in Europe as well, where the companies that haven't done that have run into some serious problems on this. The other piece that you mentioned is this whole idea of consumer behavior. You know, what do consumers respond to? What do they value? One of the things that we've really started to learn is, as an industry, how little we understand the consumer. And I think largely it ties back to the limited interaction, really, between utilities and consumers in the past. So really trying to understand what they value, what's important to them, how do they react to different types of signals. And this is a rich research area that we've just launched a research program within EPRI on customer behavior and really understanding how do they respond to signals and what do they value. Yes,
Then just a few comments. Most of the time when speaking about smart grids, we talk about distribution grids, actually. And my question would be, how do you integrate that in the big picture, meaning in the transmission grid, which is already interconnected at a large scale? For instance, in Europe, we are currently building a whole interconnected power system, one single market. And when talking about local optimization, how do you have this consistency between this local and global vision?
So one observation on that is one of the reasons why we've focused more on the distribution system and probably even more on the customer system is because in the past we've put an awful lot of intelligence already into the transmission system. One way I've heard it said is that the grid tends to get dumber the closer it gets to the customer. And that's why there was so much focus around smart metering systems, because that connection between the utility and the customer really had never existed, and so that was all new. That was all new ground that was being plowed. The distribution system, again, there has been some automation that was put on the distribution system, but not in large numbers, not at large scale. The transmission system, though, now there was a tremendous amount of work that has been put into that, but there's still more that needs to be done. And the idea of really enhancing situational awareness so that operators can see what's happening on the transmission system is one of those key areas. Incorporating phaser measurement units, California, the West Coast has been one of the real early pioneers on that. But really enhancing it and tying that information in real time back into the energy management systems and really giving that making that a tool for operators becomes a real challenge.
I know there are a couple of more questions, but unfortunately we have to move on. Thank you very much, Don.